Hello students, myself Anita Chaudhary working as an assistant professor. Uh, in this lecture we will discuss about the real-time applications. So firstly you have to know about what is the real-time system, basically uh, it does, and where is the need of the real-time systems, and the kind of applications where the real-time systems will be used, and these slides are prepared from the real-time system book, and it is written by Jan W. S. Liu from the Pearson publication. And in the coming lectures we will discuss about the real-time systems, the characteristics of the real-time systems, what kind of scheduling can be applied in the real-time systems, how the real-time systems are different from the normal systems, and the timing parameters which are applicable on the real-time systems, and how these systems are differ from the normal systems, what kind of timing parameters are used in these systems, which may not be used in the normal systems. So basically first I'll told about the, or I we can discuss about the uh, what is real time system. So any system where a timing response by the computer to external stimuli is vital is a kind of real time system. So basically the timing is a major part or major characteristics in the real time systems. So we can also say that the real time systems is required to complete the real time task and deliver the services of these tasks on a timely basis. Like, if we can talk about the real time system, if we'll talk about the real time system, those real time system should include, can include the digital controller, command controller, signal processing units, and telecommunication systems, which may be applied in real time scenarios. Like when we fly, the real time system schedule and monitor the takeoff and landing of our plane and make it fly, maintain its flight path, and keep it out of any harms in the way. Like, or the next example is like when we are ill, and the doctors may monitor and regulate our blood pressure and heartbeat, and when we are good and out of sick, they can entertain us with the electronic gaming, and we can enjoy our rides, and these are all about the real time system applications. So what is the need of the real time system? This is, I have already told that the need of real time system is required to complete real time task in a timely basis, and should deliver their services in a timely manner. So in the next slide we will discuss about how the digital controller is used in the real time systems. So uh, the controller can be used in the sensors and actuators, and try to control and real-time environment. So in the next slide, in this slide we will discuss about how the digital controller is applied on a real-time environment. So um, many of the real-time systems are embedded in sensors and actuator and function as a digital controller. Like in this block diagram, the term plant is referred to controlled system, like an engine, a brake. Brakes can be in the cars, in the aeroplanes, etc., and an aircraft, a patient. So the plant can be anything. So the state of the plant is monitored by sensors and can be changed by actuators. So sensors are continuously or uh, uh, regular interval of time or irregular interval of time. Sensors are basically monitor the system, and actuator is basically apply the control on that real time environment. So the actuator is pass this control the environment if the environment is dislead or having the some other kind of properties are censored, then the actuator is control this environment actually. So the real-time system estimate from the sensor reading the current state of the plant and compute a control output based on the difference between the desired space and the actual state of the plant. And this computation is done by the control law computer, and the output is passed to the actuator basically. So the actuator brings the plant to the closer state which is desired uh, state of the plant. So and the desired space is feed it using the reference inputs. So this is all about the how the digital controller can be work in the real time systems and how the real time system is basically work. So this is all about this digital controller theory. And you can that like the plant in the block diagram refer to a controlled system like engine, brake, aircraft, etc. And these content I have already discussed. So next real-time system example is the signal processing. So most of the signal processing applications have some kind of real-time requirement. Now we focus here on whose those applications whose response time must be under a few milliseconds to a few seconds. So like digital filtering, video and voice compression and decompressions, and radar signal processings. So in the next slides we will discuss about the how the radar system is actually used, the real time characteristics and how real time systems are work there. So in a radar system, a signal processing applications is typical a part of large systems, because in the case of the radar systems the signals are processed uh, in a regular interval of time. If you have seen the Pokhran movies, then that is the best example of the radar signals they actually used. So the what is mm, done in the radar systems and how the radar signal processing is actually work. So a signal processing applications is typically a part of large systems, and in the case of the radar signal processing basically in this signal processing we have used the signals to search an object of interest which may be appeared or come into the coverage area. So the radar scan the area by pointing its antenna into uh, in one direction at a particular time instant, and during the time the antenna dwells in a direction, it first sends a short radio frequency pulse, and then it collects and examines the echo signal returning to the antenna. So the basically the computation is done on this echo signal which is returned to the antenna. So the echo signal consists slowly of background noise if the transmitted pulse does not hit any object. So if there is no object is detected in the surrounding and surrounding environment, then the echo signal is consists slowly of background noise only. So whereas if there is any object, and then the uh, reflective object is appear at a particular x meters from the antenna, then the echo signal reflected by the object return to the antenna at approximately 2x divided by c second after the transmitted pulse, where x is the distance from of distance of the object from the antenna, and c is the uh, speed of the light, which is 3 multiplied by 10 to the power 8 meter per second, which is the speed of the light. So the echo signal collected at this time should be stronger when there is no reflected signal. So from the uh, strength of the signal, we can detect that there is an object in this area or not. So if there is an object is there, then the received signal is strong enough, rather than the there is no object. So if the object is moving, uh, if there is an some object which is moving in the detectable area, then the frequency of the reflected signal is no longer equal to the transmitted pulse. So the amount of frequency shifted is proportional to the velocity of the object, or we can use the concept of the Doppler shift here. So by examining the strength and frequency spectrum of the echo signal, the system can determine whether there is an object in the direction pointed by the antenna, and if there is an object is there, then the position and the velocity are computed using the echo signals. So this how the radar signal is basically work, and this is an totally real time environment. And in this signal, like we have discussed about the distance and the received frequency and the echo signal, these are actually related to the timing parameter. So basically real time system having the timing properties. So the third example is the real time database. So the term real-time database refers to a diverse spectrum of information system ranging from stock price quotation system to track records databases to the real-time systems. So a real-time database contains objects which can be called as image object if the object is carry the images and that represent the real world objects. So the attributes of an image object are those that having the real world objects. So the if the object is carry the real world object, then the information is holded by that object should be real time information. Like an air traffic control database is holding in the database, then that the images is contained in that database should represent the aircraft in the coverage area, and their properties should be real in the sense like the velocity, the position, the angle from the measurements are taken. So the object should keeps the real time parameters. So the attributes of such an image includes the position, heading of the aircraft, like this is an real time parameters. So the value of these attributes are updated periodically based on the measured values of the actual position and heading provided by the radar system. So basically the aircraft are always keep tracking to control the system that where it is going, how, what is the altitude of the aircraft, what is the position currently, and at what speed it is moving. So the aircraft system is basically work under the real time environment. So the real time database having some of the properties like absolute temporal consistency, relative temporal consistency, and consistency models. So in the case of absolute temporal consistency, the temporal quality of real time database is often quantified by parameters like age, temporal dispersion, etc. And a set of data object is said to be absolutely consistent if the maximum age of the objects is set in no greater than a certain threshold. So the real time objects are carried forward whose temporal distance bit is less than the certain threshold, and other objects are discarded at the time of the taking the decisions. So next is the relative temporal consistency. A set of data object is said to be relatively consistent if the maximum difference in the age of the objects in the set is no greater than the relative consistency threshold used by the applications. So it is also useful if we talk about the aircraft systems though. So if aeroplane is moving from one position to another position, then the previous history of the plane can be not useful at that time, because the current situations are handled in these kind of environments. So we should work more on the current situations rather than the previous situation. The previous situations are basically useful in deciding the path and the height of the airplane at a particular moment of time. So they may be useful also, but the current data is more useful in the real time systems basically. So next is the consistency model, the use of similarity as a correctness criteria. So similarity is a one of the important term in the real time system. So similarity as a correctness criteria of real time database, or we can say that the two values of the data object are similar if the difference between the value is within an acceptable threshold from the perspective of every transaction that may read the objects. So this is also hold by the real-time databases. So on the basis of the different real-time applications, the real-time applications can be divided into four categories. One is purely cyclic. Next, the applications can be in the category of mostly cyclic, and third category is the asynchronous and somewhat predictable in the nature, and the fourth category is the asynchronous and unpredictable in the nature. So these are discussed one by one. So first is the purely cyclic. In this case, the every task is in a purely cyclic applications are executed periodically. So in this kind of applications, the task, each of the task I have mentioned here, every task. So each of the tasks are executed periodically, like uh, even if the input output operations are pulled, and its demand, its resource demand like computing demand, computation demand, and storage demands may not change very significantly from period to period, like real time monitoring system. So in this kind of applications, the resource demands are statically may not change, because the task execution scenario is almost same in every periods. So these are type of calendar type of scenario is there. Next is the mostly cyclic. Mostly cyclic means most of the tasks in this kind of applications are executed periodically, not each of the tasks. So mostly cyclic means most of the task. So the system must also respond to some external events like fault recovery, external commands asynchronously. So like process control system are come into the category in the mostly cyclic, because most of the tasks are executed periodically. So next is the asynchronous and somewhat predictable. In this category, some of the applications like multimedia applications and radar signal processing applications, tracking systems, in these type of applications, most of the tasks are not periodic, because the sometimes we use the radar signal for detection of an object, and we may not be sent regularly the signal. We sometimes we use, if there is an chances of objects in the particular the radar signal area, then we use the radar signal for the for detection of an object. So this kind of scenario is basically non-periodic and asynchronous, we can say. So the duration between the consecutive execution of task may vary considerably. So there is no relationship between the first event and the next events, or the variation in the amount of resource demand is different periods may be larger. So the if the scenario is completely not completely, we can say that there is no predictable environment, then how we can assume that these resources are requirements. So the resource demand is also vary from period to period, and however these variation have either bounded range or unknown statics. So the uh, multimedia communication, like if we are doing something in a week or in a month, then we can categorize these application in asynchronous and somewhat predictable, because the range is there but not fixed. So the event may be performed at any moment of time within that range. So next is the asynchronous and unpredictable. When the situations are not predictable, like tsunami is there, and like coronavirus is there, so these are the unpredictable situations, and also they carry the real time situations. So the applications that react to asynchronous events and have tasks with high runtime complexity belonging to these type, like intelligent real-time control systems. So in this kind of applications, the environment is completely unpredictable, and we cannot be able to predict when a particular task is will become, and when the what kind of resources they basically require. The all the situations are handled at the real time situations, when mm, they will be occurred at that time, the resources are arranged and the requirement will be fulfilled. So thank you so much. This is complete about the type of applications and the need of the real-time systems, and the different categories of the real-time applications. In the next lecture, we will discuss about the real-time uh, systems basically, and what are the real-time tasks, how the tasks are categorized into the real-time systems. So thank you.